All right, so we're going to continue on with what we started last time. This is some EOC review for you guys. And we'll just continue on with that. We'll do some more sample problems, go over what we need to know. All right, so where did we leave off? Looks like this is our next guy. Okay, so this one I had to spread over a couple slides. It was a pretty lengthy thing. Okay, so this is the production cost in thousands of dollars. And yes, they really do this kind of stuff in business. For a toy company, and the manufacturing a ball, and this is the model that they use, where X is the number of the balls that they produce every day in thousands. And this shows basically cost versus profit is what we're going for here. So these functions that they use in this respect is to maximize their profit. If they don't make enough of these, then the production cost per ball is too much and they don't make enough profit. If they make too many of them, then they don't sell enough of them and they got some sitting on the shelf. So they're trying to find that optimum area where it's like, this is the number that we need to produce, this is the price that we could charge for them, and basically try to maximize our profit. Okay, so that's what we got going on here. So this chart again is going to be cost and then versus the number sold. So X is the number sold. Okay, so that's what we got going on here. So that's just the intro. So I want you to see the intro, but the actual question's on the next slide, and I put the graph with it because that's what will help you solve it. Okay, so it says the company wants to keep its production costs at or below 125,000. Okay, so the cost here, this is 125, so this is 1,000. So this is this line coming across here. So this is basically saying we want to keep our cost below this value. So up here, our cost is starting to maximize out. Okay, so we want to stay below this line. So we need to figure out how many of these things we need to make. Okay, so that's where we're at with this. So let's go ahead and check out the next part. Okay, so it says, what is a reasonable constraint for this model? Okay, so what this is asking is what values would we use here to figure out how many of these things we should produce? So they don't want to be in this area, right? Because this is more than 125,000. So as you can see, a lot of these problems are just picking stuff off charts and graphs. Okay. So it says, what is a reasonable constraint? In other words, what is a possible number of balls they should produce in order to stay underneath that cost of 125 grand? So take a look at the answers and see which one you think is correct. And then pop an answer in the text chat when you got it. Okay, so we have an answer of B. What about the rest of you? You agree? You disagree with that? What do you think? So let's look at B. So we start here at 2.62, and it goes up, and then it comes down over here at 26.55. Now, this is above the cost of 125,000, right? So this is more cost than they want to spend. So this is not your guy, okay? Because this is above the cost they're looking for. All right, so by process of elimination, what we can do here is we say, okay, so that's higher than they want to spend. Now, can we produce a negative number of balls? Can we produce a negative product? Is that even possible? No. So notice two of our answers have negative numbers. So that would just leave this guy. Okay. So chances are they're probably not going to produce here because that's probably not going to be enough. But they could. So probably the part of the graph they want more likely is over here. But it could be either one of those. So that's why there's two pieces to it. So again, they want to stay below this line here of 125 grand. So does that make sense? Now, if they wanted their cost to be above 125,000, B would be your answer. Okay? Questions? All right. Okay, so like I said, a lot of this stuff is just picking stuff off charts and graphs. It's not too bad. All right, so how about this one? All right, so this is just a system of equations. So I'm going to give you guys a couple minutes to work on this. What they're looking for is an answer for X and an answer for Y. You can do these using substitution. You can do these using elimination. It's really your pick. So take a couple minutes, work on that, and see what we come up with. Okay, so if x equals 4, what does y equal? Okay, so to check yourself, we could go back in here real quick, right? So we're saying that x equals 4, right? So if we plug that in here, we would get 4 times 5, that would be 20, right? And then y equals 2, right? 2 times 2 is 4. So 20 plus 4 equals 24. Good. Now let's look at the other one. So if y equals 2, that'd be 5 times 2, that's going to be 10, equals x equals 4, so that's 4 plus 6. Excellent. Nice job. So x equals 4, and y equals 2. So they just write it like this. They write 4, 2. Okay, now, if this question was a multiple choice question, that would be your best bet, is to go ahead and just plug in the numbers and see which one works. Okay. So how did you do this, Chloe? Did you do this by substitution, elimination, or did you just plug in numbers and find it? How'd you do that? What method did you use here? Good job, by the way. Just plugged them in? Okay. All right, well, good job. You figured it out. Okay, so the way we could do this is there's substitution and there's elimination. I find elimination a little easier. So what we could do is, notice up here we've got so many x, so many y equals 24. Over here, the x is on the wrong side, so we need to move him over here. If we did that, then he becomes minus x. So then this would be like this. We'd have 5x plus 2y equals 24. And then over here, we'd have minus x and then plus 5y equals 6. So I just moved him over. Okay, so elimination means we want to get rid of one of them. It'd be easier to get rid of the x because he's already negative. So what we need to do is we need to multiply this whole equation by 5. All right, so I'm going to rewrite this guy over here. So we're going to have, this guy's not going to change. 5x plus 2y equals 24. So this guy we do distributive property, right? So this would be minus 5x. That's what we're going for because those will drop out. And then we go plus 5 times 5 is 25y. And that equals 5 times 6 is 30. So then we just add column by column, right? So this guy's 0. That's what we expected. They're going to cancel. So I've got 2 and 25. That's going to be 27y. And then 30 and 24 is 54. We divide both sides by 27. And we get y equals 2. Perfect. So then we can go back to one of these equations. We can go back to this one. So if y equals 2, then you have 5 times 2, right? So that's 10, equals x plus 6. So it'd be 10 equals x plus 6, which is basically saying what number do we add to 6 to get 10, and then x would equal 4. Okay? But Chloe assumed, and rightfully so, that we weren't going to have any weird numbers. There wasn't going to be fractions or anything like that for this. So it looks like she plugged in some numbers until she got it to work, which is fine too. Okay? Good. All right, let's move on. Okay, so this one has a couple parts to it. So it says sewer removes the plug from a trough. You guys probably didn't know what a trough is, but that's okay. To drain the water inside. It's basically a big tub that they usually feed animals in. So this would be like on a farm or something like that. So it says the volume in gallons in the trough after it's been unplugged can be modeled by the following function, where T is the time in minutes. It says select the correct property, say that 5 times fast, that will give Sue the amount of time it will take for the trough to drain. So is that going to be a maximum, a minimum, a y-intercept, or a 0? What do you think? Well, when the water is at a maximum, that is when T equals 0. That's when time equals 0. So she hasn't taken the plug out yet. Okay. So if time equals 0, we don't really know how much time it's going to take to drain at that point. So we can probably cross that guy off. All right, so what else are we looking for? So it would be a minimum. That's true. But in this case, if there's no water in there, how much water is left if there's no water in there? Yeah, there we go. So that's kind of tricky because it is a minimum. You're right. But in this case, we know what the minimum is because the minimum is the thing's drained out and there's no water in it. So it's 0. Okay, good. Okay, so the next one here says select the expression that will reveal the property. Reveal the property? What are they talking about, right? Okay, so here's what we're talking about. So when the thing is drained, there's no water, right? So f of t, or the y value, right? So f of t equals this expression here. Okay. And when there's no water, that means f of t is 0, so this thing equals 0, which we just figured out for this guy, right? Okay. So this is when y equals 0. So that first one is plugging in 0 for x, so that's not it. Okay. So next question is, can we factor this guy? All right, well, let's see if this thing does factor. So what you want to do with this guy is if we multiply him out, do I get this guy back? Okay. So let's see. So we got 2t times 2t, that's going to be 4t squared, right? And here we've got minus 14t, and here we've got minus 18t, and then plus So we have minus 7 times minus 9 is plus 63. Put these two guys together, there's my minus 32 t. So we can factor this guy. All right, so if we set him equal to 0, this will tell us how much time it takes for this thing to drain. So I think that's our guy. Does that make sense? So you want to see which one we can go back and get this once again. So that's all they're going for there. Questions? So if we set that equal to 0, we can figure out the time it takes. Yeah. Cool. Because these other two guys, this is vertex form. This one and this one are both vertex form. Now the problem with vertex form is this is going to be like this, right? So the vertex form is here. So we're going to stick with B. Okay? All right, let's go ahead and move on. Okay, so this is another one I had to do in 2 parts. So we've got our intro here, and then I'll leave the chart on the next part and we can figure out what's going on. Okay, so Florida has 67 counties. I did not know that, but I'm still kind of new around here. And Texas has 254 counties. I think it's because Texas has a lot more land and more people, but not that many more people. There's probably more concentration of people here. Ohio has 88 counties, by the way. I knew that, but I lived there a lot longer than I've lived here. All right, so it says the mean population of the state of Florida by county is 291,834. Okay. With a standard deviation of 467,000. Wow. Okay, so we need to talk a little bit about standard deviation, what that means. And a median of 107,000. Okay. So mean population in the state of Texas by county is 104,000. So see, less people per county, but more counties, right? Standard deviation of 374,000 and a median of 18,293. So this is kind of all over the board, isn't it? Okay, so some data for both states are shown. Okay, so this was the stuff we were talking about pretty recently about the quartiles. This is like the top 25%, the bottom 25%, the middle 50%. We were talking about that stuff. Median, again, is if you arrange the counties by population from smallest to biggest, then you would get the median is the guy in the middle, and the same thing over there. So there's actually a county in Texas only has 95 people. That's crazy. And the biggest county has 4 million people. I would assume that would probably be Dallas area. And here in Florida, we got our largest is about 2.6 million. Now I don't know how recent this data is, but I know that Tampa alone is about 2.5 million. So I don't know if Hillsborough County is the biggest population here, or maybe it's down by Miami. I don't know if you guys have any idea on that one either. So it says a business moves its corporate location from Texas to Florida. Of course, everybody's moving to Florida. I read 330,000 people moved to Florida last year. That's a bunch. Okay. So it says, as a result of the move, 8,193 people moved from the largest Texas county to the smallest Florida county in terms of population. So they moved from some great big place like in Dallas to a county probably out in the middle of nowhere here in Florida. Interesting. Okay. So that's what's happening so far. So let's check out the actual question. We may need to pop back and forth here, but all this stuff would not fit on here. And I know this is a pain when they give us these like huge questions with lots of reading, which nobody seriously likes. All right, so let's see what happens. Okay, so we know that the business moves. It says select the population statistic that will be affected by the population change. Okay, so what we said here was, how many people was it? Let me get that figure real quick. So right here, 8,193. So that means that 8,193 are going to leave this county. I can get this thing to right, that would be awesome. So minus 8,193 here. And up here, we're going to add those guys. So it's pretty much going to double the population of that county. Okay, so then same thing here. Let's do that again. So minus 8,193, and then add 8,193 here. Okay, so it says, as a result of the move, it says select the population statistics that will be affected by this population change. Okay. So the median in Texas. Okay. So that's the guy in the middle. So this all came off of the largest county. It's still the largest county, so the order of these guys is not going to change, right? So for that one, I would say the median, actually in Florida as well, that's still going to probably be the smallest county. Well, we don't know that for sure. So there's a lot of different things that can go on here. So the interquartile range, that's the middle 50%. This is sort of on the outside, right? So if we add a few people at the bottom of the food chain for Florida and we subtract some people from Texas, the median 50% is probably going to stay the same. So I think we can go with that one. So again, this is just kind of logicking this thing out. Okay, so the mean in Texas. So mean is the number of people per county, right? So there's 254 counties, and now this county has lost 8,193, right? Okay, so if you take away some from the average, your average is going to go down. So that's this guy. Okay. Now the mean in Florida, like I said, probably is not going to change, because that still may be, even though we've doubled the size of the county, it still might be the smallest county. But things really haven't moved around much, right? And that's another thing. A median doesn't change nearly as much as an average. Okay, so we're probably going to keep that guy the same. Okay. So standard deviation would be how much is the data spread out. Okay. So obviously the data is pretty wide here because we had the smallest county only had 95 people, and the biggest county had over 4 million. Okay. So standard deviation probably not going to change much at all. It might decrease a little bit, but probably it's going to stay about the same. Okay, so again, this is all just kind of logic stuff. So the only thing that's changed the most is the mean. Just remember that. When they like stick something at the end, I mean, let's talk about like my LeBron James example. If you buy a house in Ohio, or Akron in particular, like I say, it's probably about 150,000. But if you average LeBron James's $60 million mansion into the price of everybody else's house, the average is going to go up. Okay, but the median won't change hardly at all, because all we've done is we've added one house, which means we move up one in the list of properties from lowest to highest. If you're right in the middle, like I said, it's going to be around 150,000. If you move up a little bit, it might go up, a couple bucks, but it'll still be around 150,000. So this is why they use median, because median is what they call resistant to an outlier. And an outlier, again, is a number that's like really, really out of whack, like way big or way small, usually way big. Okay. So that's just something to remember when you're looking at these kind of problems, just to kind of logic them out. Is the mean will change a lot faster than the median. Okay, and if the median doesn't change much, that means your interquartile range doesn't change much. And your standard deviation means we haven't really spread the data much farther or closer. So, I mean, it might decrease just a little bit. So, I guess if they really want to get technical, we could probably say this guy would probably decrease, because now the population would be slightly closer together. It's not going to decrease by much, but they would probably officially go with decreased, now that I think about it a little bit. Okay. So again, this is more just using your logic skills. This is not any serious math going on here. Okay. But, they want you to be able to think for yourself. That's a lot of this stuff. And you have to keep that in mind too, is like, when you take math class and everybody says, well, when am I ever going to use this? It's like, well, you're probably not, unless you go into some kind of tech field. But what they're doing is they're basically, you're doing weightlifting for your brain. It helps your brain get stronger. It actually does make you smarter. They've discovered that through research, that if you try to solve complicated problems and you think about stuff like this, that your brain actually develops more synapses between different parts of the brain, which is like you've got more highways, so it's easier to get from one part of your brain to the other. So you technically will get smarter. I know that's crazy to think. When I was your age, I never would have thought that something like that could be true, but they've pretty much proven it time and again. So just a little side note there. All right. So let's see if we got time to check out one more. See if it's a short one. If not, I'm going to go ahead and call it. All right, let's see what we got today here. So again, picking stuff off charts and graphs. So it says, the graph shows the number of acres and millions of farmland in the United States from 1975 to 2008. So so this one's pretty easy. Which statement describes the average rate of change of the graph? Okay, so average rate of change is literally slope. Anytime you see this phrase, this is slope, right? Okay, so let's take a quick look at our answers here. All right, so everybody decreases. So the question is, which one of these guys would be the best? All right, so what we need is we need some points here that we can work with. So we try to find some places where it hits right on the line. So like right here would be a good one. Okay, so that means in 1975, we were at about 1060. Okay. And this is pretty steady decline here, right? So let's use this guy. So this guy here is saying that in 1980, we are down to 1040. Okay. Supposed to be 1980. There we go. Okay. So the average rate of change, what we can do here is we say, all right, so we went from 1975 to 1980. So that's 5 years. Okay, so that's going to be the bottom of this because that's our change in X, right? These are our X values. These are our Y values. Now this one went down about 20, right? So 20 divided by 5 means your slope, and this is going down, is going to be -4. All right, so how does that work with what we've got here? So it says the number of farmland in the United States decreases by 0.21 million each year. Okay, so if we take -4 and we divide that by 5, that would be 0.8. That wouldn't be 0.21. Okay, so it's not that one. So it says decreases 4.8. That's pretty close. Because if you're going down 4.8 and you take that times 5, that's 24. This is actually a little below the line. So 20 is just an estimate. So you got to kind of estimate these things too. Okay. So this one says decreases 160 acres over 33 years. So 33 years, that would be the whole thing, right? So we went from 1060 to decreased by 160 acres. So 1060 down to 920. So no, that doesn't quite work. And this says for every 5 years, the amount of farmland in the United States decreases by 20 acres. Okay, so it's actually 20 million acres. So they're kind of messing with us there too. So I'm thinking this is probably our boy. But again, you just got to logic these things out. Okay. And on that happy note, we'll go ahead and stop for today. Yeah, I would have agreed with you on that one, Chloe, except they didn't put million here. So you got to really watch these guys. Okay. All right. So once again, I appreciate you guys stopping by. I've already got attendance. So we'll see you next week.